Okay, calculus, we continue on. This is from 2015, problem number 3. You can see that you have a table in front of you. Again, I would encourage you to have, these type of documents out with you as you're working. That's what I'm looking at so I can see the problem. You can see my work. It tells us that Johanna jogs along a path from 0 to 40, so from 0 minutes to 40 minutes. And you've got this differentiable function v, so you're given the velocity function. The first question says, use the data in the table to estimate v prime of 16. So v prime of 16 is a derivative, but when you're given a table of values, you can't really find the derivative. So if you look at what we have here, there's no velocity at 16, okay? But you can tell from 12 to 20, you're going up. It's going from 200 to 240. So when it asks for v prime, it's looking for a rate of change, but as it says estimate, we're going to choose a point before it and a point after it. So we're going to choose v of 20 minus v of 12 divided by 20 minus 12. And what that's going to give us is v of 20 is 240 minus v of 12 is 200. And we're going to divide that by 20 minus 12, or 40 divided by 8, which is 5. And they're going to want a label here. And we are in meters per minute. Okay, so that's her average velocity during that time. I should say her velocity is increasing at a rate of 5 meters per minute. So it's 5 meters per minute squared, actually, because this is the rate of change of velocity, so we're getting acceleration. So 5 meters per minute squared. I'm also just taking a glance at the answer keys over here to make sure that I'm not missing anything. And as I look, sure enough, yeah, they said 5 meters per minute squared, so that is important. B says, using correct units, explain the meaning of the definite integral 0 to 40 of the absolute value of v of t dt. And if you remember, when we do the absolute value of the velocity function with an integral, that is total distance. So that is the total distance. They love labels, so distance in meters. Johanna has jogged from time equals 0 to time equals 40 minutes. So they're going to love that type of explanation there. So just remember that absolute value means total distance, whereas just if you didn't have the absolute value, that would be the displacement. And that's important because you can tell by looking at this that there's actually a time where she has negative velocity. So that means she's jogging in a different direction. And so her displacement and total distance will be different in that situation. It says to approximate that value using right-Riemann sums with 4 subintervals. Right-Riemann sums. So if I look here, I have 1, 2, 3, 4. And as we go to calculate this, what we're going to do is we're going to look at that first interval. So the width of the first interval is 12, and then 8, and then 4, and then 16. And we have to multiply it by the height. Well, the right side height is going to be 200, and then 240, and then negative 220, and then 150. So again, we take that 12 times 200 plus 8, that's the next width of the interval, times 240 plus 4 times negative 220, positive 220. Why? Because absolute value, we take the positive. That's a common mistake for this kind of a problem. Plus 16 times 150. Now, this was a no calculator problem, and so this all had to be computed by hand. I think they're going to allow you to use your calculator on this stuff, so I'm going to go ahead and just type that in. I've got 12 times 200 plus 8 times 240 plus 4 times 220 plus 16 times 150, and I get 7,600 meters. And that's a good answer right there. Part C says Bob's riding a bicycle. So now we got Bob entering the picture. And his velocity is B of t is equal to t cubed minus 6t squared plus 300. And it says find Bob's acceleration at time equals 5. So acceleration of time equals 5. Well, acceleration of time is equal to the derivative of his velocity function, which is going to be 3t squared minus 12t. And now you're going to plug in 5 to that. And so a of 5 is going to be 3 times, that'll be 25 minus 12 times 5. So that'll be 75 minus 60, which is 15 meters per minute squared. That's our label. Because again, we're finding acceleration, so we have that squared. And part D says, based on the model B from part C, find Bob's average velocity. So B of t, that is, right there, B of t is in fact his velocity function. We're going to find the average value of the function. The way we find average value of the function is we do the integral, 0 to 10, and then we multiply by 1/10. So the average value of a function, we do that integral thing, we divide by the width of the interval. So we need to find the antiderivative now of his velocity piece, which is t to the 4th over 4, and then minus the antiderivative of 6t squared. That looks like that's going to be 6t to the 3rd over 3, so 2t cubed, and then plus 300, so it's going to be plus 300t. We're going to evaluate that at 10 and at 0, and we're going to take that whole thing and multiply it by a 10th. So they love to see your work, so please make sure that you're extending your work all the way through here. And I'm going to, especially for the sake of time, I'm going to plug that 10 in there. So 10 to the 4th, we're going to divide that by 4, minus 2 times 10 raised to the 3rd, plus 300 times 10. And then you multiply it by 0.1 or 1/10, we get 350. So that is equal to 350 meters per minute. So that's the average velocity we're looking for in the outcome. So average velocity. I'm checking out the answer key here, and it looks like everything is checking out. We got 9 out of 9 on that guy right there. So that's problem number 3. That was a quick one, only 8 minutes there. So we will move along. Good work, folks.